Yes. That's about
We're good.
it's like as they already have like that. Hello, hello. Good evening, afternoon. I don't know what 5 is considered actually,
It's evening.
but
Yeah.
I hope you're all doing well. Thank you all for those who came in person, and thank you all for those who are joining online. This is our first FAST workshop for the semester, and it's pretty exciting. Just double checking that I'm audible. I will, yeah, going once, twice, 3 times. Sold. Okay. But yeah, so again, for those who maybe are new here, or if you're just filing in, if you could please take a moment to sign that QR code or sign in to our QR code. I need to do that too, actually, but leave that on my phone.
Everybody signs in.
Yes, this helps us inform the school and ASI how many people we are serving and can give us more leverage in terms of advocating for more funding for more cool things, such as the AWS instances that are currently charging me up the wazoo right now. So if you could please do that. Much appreciated. This one, okay. And then for those who are completely new here, these are our Discord and Linktree links. Please feel free to join those as necessary. This is how you will keep up with everything happening around the club and keep informed about cool things like this that we're doing. So I'll give you all a moment to do that briefly. Alrighty, going once, twice, 3 times, sold. All right. All right, so some upcoming announcements. Our friends over at Cal State Fullerton from the Offensive Security Society, or OSS, are having their OSS conference. They're trying to do a free mini kind of CSU DEF CON, and each school will be representing a village. Cal Poly will be doing forensics, and we've been invited to do a demo. If you are interested in helping us out in putting that together, we would love to hear from you. And then if you are interested in simply attending to learn more about cyber within the CSU, I would definitely recommend checking that out. We will be sending out the registration link after this meeting on Discord. So keep that eye out for that. And then next Tuesday, we have a speaker coming in from Sumo Logic. I believe they're coming in person, so that should be pretty exciting. I definitely recommend for those, thank you all for those who came in person, by the way. But being able to shake hands with those speakers and have them be able to put a name to a face is definitely something I would recommend in terms of building your network. But yeah. And with that, let's get into it. We've put together a very, I think, pretty exciting introductory to cyber and Kali Linux workshop for you today. And I'll pass it over to Alex for taking this away.
Sweet. Okay, so our Intro to Cyber / Kali Linux workshop is going to be based around kind of continuing off some of the concepts that we talked about last Tuesday meeting. We're kind of going to be going over just a basic overview of cybersecurity fundamentals, very brief, just because with the time we have, this is a 2-hour workshop. If you guys saw that the graphic on the graphic, it was from 5 to 6. Sorry about that. That was a mistake. It is 5 to 7. And that will be just the same length for all of our workshops on Fridays. We'll be going over basic cybersecurity fundamentals, things like operating systems, networking, as well as a little bit of a hands-on practice in Kali Linux. So I hope you guys are excited for that. Just like I said before, fundamentals, operating systems, file systems, networking. We're also going to be going over some of the common tools that are pre-installed in Kali Linux, as well as exploring cyber topics outside of this workshop. So here I have a 9-minute video on what exactly is an operating system. This video is just going here to cover a lot of the terminology and words that we may refer to throughout the workshop. And let's go and give that a play.
Every time you open an app, save a file, or even press a key, something in the background makes it all work smoothly.
That something is the operating system. It's the core software that manages your computer's hardware, runs your programs, and keeps everything in sync. But how does it actually work, and what's inside it? Let's take a closer look. An operating system, or OS, is the crucial software that manages a computer or device's hardware and software, making it possible for users to interact with their devices. Acting as an intermediary between the user and the machine, the OS ensures that everything runs smoothly by providing a platform for applications to execute and managing access to hardware resources. From simple tasks like opening a file to complex operations like managing memory and networking, the OS makes it all possible. Without an operating system, a computer would be unable to perform any tasks and the hardware would remain inert. It's the backbone of any device, whether it's a smartphone, laptop, or server, and its efficient operation is key to the overall performance of the system. Now let's look at the core responsibilities that allow the OS to keep everything running smoothly. One of its key functions is handling system resources, deciding how and when hardware like the CPU, memory, and storage should be used. It also coordinates processes by starting, pausing, or terminating programs, ensuring they don't interfere with each other. The OS keeps track of memory usage, allocating space when needed and freeing it when not. It also takes care of file systems, managing how data is stored and retrieved on disk. Another important function is controlling input and output, making sure devices like keyboards, printers, and network cards communicate effectively with the rest of the system. Together, these functions form the invisible framework that allows software and hardware to work in harmony. Next, let's take a look at the core components of every operating system, the kernel and the shell. The kernel is the heart of the OS, responsible for direct communication with the hardware. It controls critical functions like managing the CPU, handling memory, and ensuring that different processes run efficiently without interfering with one another. Depending on how it's structured, the kernel can be monolithic, where all services run in a single space, like in Linux, or a microkernel, where only the most essential functions operate in the core while others run separately, as seen in some embedded systems. There are also other kernel types, such as hybrid kernels, used in Windows, and nanokernels, each offering different design trade-offs. Surrounding the kernel is the shell, which acts as the user interface for interacting with the system. This can be a command line interface, such as Bash on Linux, or PowerShell on Windows, or a graphical user interface, like Windows Explorer or macOS Finder. While the kernel does the heavy lifting behind the scenes, the shell provides users with a way to give commands and control the system. Now let's look at the different types of operating systems. A single user OS is designed for one person at a time, while a multi-user OS allows multiple users to access system resources simultaneously, common in servers and mainframes. In terms of task handling, a multitasking OS can run several applications concurrently, like Windows or Mac OS, whereas a single tasking OS focuses on executing one program at a time, typical in simpler or older systems. Desktop operating systems are built for personal computers and laptops, offering a full graphical interface and wide hardware support. Mobile operating systems, like Android and iOS, are optimized for touchscreen devices with power and resource limitations. Embedded OSs run on specialized hardware such as smart appliances, medical devices, or routers, often with minimal interfaces. Finally, real-time operating systems are designed for time-critical tasks, where responses must occur within strict time constraints, common in robotics, industrial control systems, and aerospace technology. Keep in mind that there are even more specialized types out there, and that each one of them plays a vital role in powering the digital world around us. Before we dive deeper, it's important to understand how the operating system actually starts, through what's called the boot process. When you power on a computer, a well-orchestrated sequence of events kicks off. It begins with the BIOS, or UEFI firmware, which performs basic hardware checks and locates the bootloader, a small program responsible for loading the operating system into memory. Once the bootloader runs, it loads the kernel, the core of the OS, which then takes control of the system and starts initializing essential services, drivers, and user interfaces. At this point, the operating system becomes fully active, ready to manage resources and enable user interaction. Understanding the boot process shows how the OS transitions from stored data into a working environment, laying the foundation for everything the user sees and does. Now that we've seen how the OS starts up, it's important to understand where it fits alongside firmware and the BIOS. These components often get confused, but they each serve distinct roles. Firmware is low-level software permanently stored on a chip that provides essential instructions for hardware. BIOS, or Basic Input-Output System, a specific type of firmware, initializes and tests hardware components during startup and loads the bootloader and the OS. In contrast, the operating system is the full-featured software layer that takes over once the hardware is ready, managing resources and enabling user interaction. While the BIOS and firmware act as the system's groundwork, the OS provides the functional environment users interact with daily. Next, let's explore how operating systems handle data through file systems and storage. A file system is the method an OS uses to organize and manage data on storage devices like hard drives, SSDs, or flash drives. It determines how files are named, stored, retrieved, and structured into directories and subdirectories. Common file systems include FAT32, NTFS, ext4, and APFS, each with its own rules and capabilities. The OS uses the file system to keep track of file locations, permissions, and metadata, ensuring quick access and data integrity. Without it, stored data would just be raw, unreadable bytes. Efficient storage management is essential for performance, reliability, and user experience. Now let's explore how operating systems manage users and control access to data. Through user management, the OS can create and maintain individual accounts, each with specific roles, settings, and privileges. Permissions are then assigned to determine what each user or group can do with files and system resources. These typically follow CRUD operations, the ability to create new files, read existing data, update or modify content, and delete what's no longer needed. On top of that, the OS enforces who can execute programs, install software, or make administrative changes. This structure ensures both convenience and security, preventing unauthorized access while allowing legitimate users to safely interact with the system, whether on personal devices or shared networks. In conclusion, operating systems are the unsung heroes of modern computing, coordinating hardware, enabling software, and managing users, files, and memory behind the scenes. From the moment a device powers on to the second you shut it down, the OS is working constantly to keep everything running smoothly. But there's still more beneath the surface. Features like built-in security mechanisms, user privilege levels, and system updates help protect against threats and keep systems stable. And as technology evolves, operating systems now support advanced features like virtualization, allowing one machine to run multiple OS environments at once. In future videos, we'll dive deeper into these areas and uncover how operating systems truly power the digital world around us. That wraps up our dive into operating system basics. If this video helped you understand how your computer really works.
So yeah, that was a really brief overview of the of what an operating system is. As you can see, it's a very complicated machine. Everything that an operating system does has several steps, and that makes it very prone to multiple different types of attacks, which we'll cover a bit in the workshop. Also, if any of the concepts in in our slides confuse you, feel free to go out and do your own research after this workshop. We'll be providing some resources as well on further learning. So the two most widely used operating systems that are used in the current world are Windows and Linux. They are the most used operating systems for the past, I'd say, 10 to 20 years. Windows is an operating system that was developed by Microsoft and is most popular amongst desktop computers. Many users use them to browse the web, use applications, play games, among other things. Linux is a more specialized operating system, but I say operating system with air quotes because Linux is mostly considered a kernel, which distributions, which are what we were going to consider operating systems for this workshop, are what it actually is. So Linux is a kernel, essentially. Linux is mostly used for servers and development applications. Most of the world's servers run on Linux or a distribution of Linux. And the modern security world focuses on these main two operating systems, but it doesn't quite mean that we're not going to be covering macOS operating systems like macOS or mobile computing platforms like Android and iOS aren't in security world either. They're just in a more niche field of cybersecurity. So a little bit about file systems. These are the hierarchical structures that organize all of our files. From the video, we know that data is represented as bits or bytes, and they are stored in file containers or files, which are files are bits are data organized into a specific container or file type. File types you probably know as like .exe or .pdf. Those are what file types are. Those extensions represent a different type of file type. A directory is a space that holds files and other directories. And a path is an address that points to files and directories. If we take a look at the diagram up in the upper right where it says Linux file system, I'm going to draw some attention to this because Kali Linux will be using this file system. It's good to familiarize yourself with a bit of each of these directories in the Linux file system have a purpose. But for this workshop, we'll just be focusing on /home. And yeah. So access controls and privileges. These are very important for operating systems because it allows users and administrators to kind of coexist on the same platform, but also make sure that users aren't able to perform unwanted actions on a computer. Most of these access controls deal with files, and they deal with the read, write, or access/execute permissions of files. For Windows, the access control system is revolved around administrator. If you've ever right-clicked on a program on your desktop and the prompt shows up that says we're an administrator, that's what I'm talking about. Administrator is basically an escalated user state where it allows you to perform many more privileged actions that you may not be able to as a regular user. As for Linux, the administrator equivalent would be the root user. The root user is especially an important topic to talk about because the root user for a system has the most amount of privileges on a system. They're able to read, write, execute everything on a file system. So that is one thing that you don't want to give attackers to, and you want to make sure that your root user is secured through a variety of different means. But then how do we execute administrator operations on Linux machines? Well, we can use a program called sudo, aka superuserdo, which allows users to execute root level actions. And a little bit about networking. When a device connects to a network, it is assigned a unique IP address that other computers or devices on the network can find and communicate to. Modern systems follow the TCP/IP model. As you can see here, the TCP/IP model is a layered network model that for each layer there is a specific standard that is used. For example, on the network layer, which is essentially physical connections or how devices are able to access a network or interconnect with each other, they use Ethernet or wireless LAN. You probably know them as Wi-Fi. On the internet layer, IPv4 and IPv6 protocols are used to assign internet addresses, essentially. On the transport layer, which are is where the transportation of actual data packets are, the TCP/UDP model is used. So the TCP model on the transport layer is different from the TCP/IP model. We won't get into that, but on the application layer, there are several different protocols, HTTPS, TLS, DNS. They're all used for things like web browsing, pulling web pages. They're used to also redirect addresses and so much more. And now we can get into a general overview of the terminal. So a terminal is essentially a way for a user to directly interface with an operating system. You probably, if you've already used Windows or Linux or Mac OS, you've probably been interacting with the system through what's called a GUI, which is a graphical user interface. That is just another way to interact with the system, whereas the terminal is a much more primitive, but also a much more powerful way of interacting with the system. We can go over a couple of general commands that are used that you may use during this workshop. These are all Linux/Unix commands, so they may not work on the CMD command line on your Windows machine or PowerShell. But these are for getting general help. You can use man and then space whatever command that you want to look up a manual for. There's also history, which provides you a history of your previous commands that you've inputted into the terminal. For file navigation, you can use ls to navigate to specific paths or directories in your file system. CD will be used to navigate to a specific directory or path on a file system. Yes.
And these are for Windows or?
So a lot of these commands are applicable for Unix systems because these are what are considered Unix commands. For Windows, they share a lot of these similar tools. For example, CD, ls, and pwd. It's not on or mkdir. But well, for the purposes of this workshop, we'll just only be covering Unix commands.
Briefly on that though, PowerShell, I believe, was designed by people who came from a Unix background. So they've designed it to be mostly compatible.
Sort of interoperable.
Yeah.
Yeah, if you're familiar with Unix commands, it's pretty simple to learn PowerShell and the CMD line on there. mkdir, make directory, is just a way to make directories on a system, and rm, which removes a file. Some more commands for getting admin privileges. Like I mentioned earlier, you will have to use the command called sudo. We can go over a bit of general overview or more hands-on demonstration of that in the actual workshop. But how sudo works is you can assign a user to a specific group on a Unix system, and they will be able to use the sudo command. For editing and viewing things such as text files, you can use nano and cat. Cat stands for concatenate, and that prints the whole file. There are a couple other viewing ways to view a text file that we can cover a little bit in the workshop, so just keep an eye out for that. And packages, this is a command usually used for administration of the system, things like updating, upgrading, installing new packages for Unix systems. Note that each command starts with sudo because package management and software management is a thing that requires super user privileges on Unix systems. Okay, now Caleb will be going over RDB clients.
Cool. Alrighty, so this is going to be the start of the fun part. For those who have signed up for a copy of the lab, you should have received an email from me with something labeled along the lines of like Kali workshop, and it should have a IP address. Now, in order to use that, you need what is called the remote desktop protocol client. This comes installed by default on Windows and I believe Mac. But for those with Linux, you may be interested in downloading one of the free software clients out there. For example, Remina. I believe that is just REMMINA.org, if I recall correctly. I know I saw a couple of people with Linux in the Zoom room previously. Please let me know if you don't have, or please let me know if you signed up for the workshop or a copy of the lab, and you have Linux and you don't have an RDP client. Whether you're on Zoom, please, especially if you're on Zoom, or if you're in person, does everybody here have Windows or Mac or otherwise have RDP? For you got Mac?
Yeah, I see a bunch of Mac pages. Okay. In that case, for those who have Windows, the client is already pre-installed. It should be also pre-installed in Windows 11. So it should be good on that end. If you have Linux, go ahead and navigate over to Remmina.io. If you are using Linux, I presume you know how to install. I believe Remmina comes in a Flatpak package, or it comes in your package manager in your distro repository. But for the Mac OS users out there, there is a program just called the Windows app. It's distributed by Microsoft, I believe. It used to be called Windows Remote Client. I can go ahead and post the link up in the Zoom, as well as we'll be going around in person to assist you guys if you need any help with installing any of the RDP clients. So. Yeah, we'll take 10 minutes to do that. If you guys in the Zoom have any problems with installing the client, feel free to shoot us a message and we'll try to get it all resolved for you.
Was apps just Windows app, right? Through the Microsoft Store. Like not too familiar.
Yeah, it should be called Windows app. Let me. Or the App Store is on the Mac App Store. Yeah.
Okay, yeah. Okay. It'll be the public IP, but more information on that to come. We have to specify a port number, but we'll get to that. No, it's probably.
Lucky you, Jack. You're on Windows, right?
Yeah, fine. Okay. So you're on it's all good, right? Just press enter. Yeah, hold on. So it's all good. And then
Yeah.
So can I do some time? So there for now. Yeah.
So do you have the Windows app installed?
Yeah, so that's right.
Oh, is that true? Okay, cool.
Hold on. I want everyone to be on the same page.
Okay, there's a way to so I'm curious to see how they were playing. Yeah, sidebar. Yeah, that one. Oh no. Oh, it would be the add button.
We did a custom AWS deployment so that already has a bunch of sample files ready for analysis. Just for single stuff. We want to be sure so that you. It is really cool word. Okay.
I am very not familiar with Mac machines. Oh, there it is. Okay, very cool. Yeah, we'll be using the just add PC link. Yeah, option.
No. So are you familiar with like cloud computing? Basically, I rented somebody else's computer and I'm giving you access to it. So like I'm renting a car and I'm giving you the keys. Okay. Yeah. And then if you break anything, it's on me, so don't break anything.
Maybe you can just go to the App Store.
Alrighty.
I'll show you the solve.
We connect to the public. Yes, it'll be the public IP. You'll have to specify a port, but we're going to try and make sure everybody who wants the copy of the lab has the copy of the lab and can access it through RDP before we continue. But awesome that you're asking those questions, right? Is there anybody else on Zoom who may be having some difficulty with either installing Windows app or installing Remmina? Okay. I will take silence as a no. Give me a thumbs up reaction if you're all good to go and or just are here to watch on Zoom.
Might take a while. But anyways. I don't know. Actually, it's quite. Actually, did you? Try to go back to the or slide and then and specify
Righty. We got one. We'll take it. Okay.
and hit action. Then yeah, you only see type into
Okay. For those on Zoom, then, if you can please just hold tight a moment. We're going to make sure everybody in person is set up with the remote desktop client. We will talk about why it may not be letting you connect briefly, Ryan.
Oh yeah, we'll go with that.
Because I didn't quite give you all of the information you need just yet.
Nicely, so to initiate an connection, it'll just plus four.
But yeah, gonna make sure everyone's on the same page first. But thank you all for your eagerness. I appreciate it.
And you can go out there, or you can it's in the calendar.
Yeah, yes, good. Okay. Okay, I take it that everybody is good.
Is there anybody in the room who hasn't installed the RDP client? Okay.
All right. In the meantime, hopefully that's a relatively quick fix. We can slow down if that continues to present some issues. But
Already installed if you
So-
search for remote.
some of you who have been excited and tried connecting to your VM already may have gotten a bit of an error message saying that it timed out or something. And that is because the custom installation that we did on AWS required me to forward RDP protocol traffic through a specific port, which needs to be specified in your RDP client when you're connecting. So in addition to your IP address, you're going to have to put colon 330 or 3390 at the end of there. And that's basically telling you, I want to connect to this computer at this IP address, listening on this particular port.
If you can spell that. And then type in where's the computer?
Hopefully that helped on the, please on Zoom, put it in the chat, be like, I got it, or I'm in, or whatever. And then for those in person, I'll be walking around, Alex will be walking around as well, to make sure you're all able to log in, or well, not quite logged in. I'll provide the credentials shortly, but you should be able to get to a Kali login screen.
That's a highlighted.
Oh, that is, yeah.
Unfortunate.
I mean, the credentials are simple enough.
Oh, yeah, true.
Yeah. All good, all good. All right, ready for the next step? Sick, I'm in sunglasses, we'll take it. Okay, so the credentials, the username is Kali, all lowercase. And then the password is Kali, all lowercase, and then 2025 09 19. I say O, but I mean 0. It's just Kali and then today's date. Got it. Thank you.
Wait, can you repeat the password?
Kali 2025 09 19. All right, give me another I'm in on Zoom if you're in, and then I don't know, in person. Okay, that didn't look like a triumphant one. What was that?
Oh, yeah, that's great. I call it companies. Yes, I think you. Or public growth. This. Site for this and see if that's easy. They can handle this. Okay, go. Code things. So here, the. Okay, yeah. They go ahead and add the Paladin and Paladin to this. So that was just the data of I don't know, ports are a bit of a complicated subject, but basically you were connecting to the right machine, but it was listening on it's like you were talking to it in a different language than it was listening for. By specifying port 3390, you're telling it, okay, I want to talk to it in this channel. And you're like actually talking to it now. But
Yeah, I forgot to mention that in the network slide. Sorry about that. But so for initiating connections between two machines, usually they would specify the machine IP address as well as the port number. And you can think about the port number as sort of like window on a house, if that makes sense. Windows can be closed and windows can be open. And in this case, some machines may have their ports open, while other ports may be closed. That's a simple explanation of ports that I can get you guys.
alrighty.
I think we should be good, right?
Cool. With that, everybody should see Kali now.
Cool.
Sweet. So welcome to Kali Linux. It doesn't look exactly like that, but you should all see that dragon in the background. And you should have, your terminals and stuff. And we're ready to get into it. Next. But first, what exactly is Kali? For those in the room, please raise your hands if you've never heard of Kali. Gotcha. Don't worry. For those who may not know me, my first exposure to computers and stuff was one HTML class, and then I showed up to college with one HTML class, and that was, yeah. So in the same boat, don't worry about it. But Kali basically is a version of Linux that has been specifically designed for security work. It comes pre-installed with a lot of tools and tools that security practitioners would like to use in their day-to-day work to make that easier. So you don't have to go out on your own and install that. Yeah. Now, most of these tools are meant for ethical hacking. Keyword being ethical. So all the things that we're doing today, our cloud engineering team has made an isolated vulnerable machine for you to exploit. And the keyword is for you to exploit. So the consent is there for you to break into these machines and look into the files and things like that.
But not other machines outside of this environment.
We do not want to be scanning things that you don't either own yourself or that you don't have permission to scan, break, denial service, things like that. So make sure you know that you have permission or that you own the thing that you're working with. Alrighty. With that, we can get into a little brief overview of what exactly is penetration testing. Basically, there are bad guys out there, and your bank, your hospital, your school has all sorts of sensitive information and systems that need to function to deliver services and keep, deliver to their customers, deliver to you, etc. They want to know that their security protocols, practices, things like that are adequate. And they are going to hire either internal or external penetration testers to act like real world hackers and try to break into their systems, try to take their systems offline, try to steal data, copy data, ransomware them, whatever the case may be. And if they can successfully do that, then the penetration tester is supposed to report out to that client, to the hospital, the school, whatever, and explain, here's what we did to break into your system or to take your system offline. And this is something that a real world bad person could try to do. But we did it and we proved that we can do it. And we are going to also provide you with this instructions on how to prevent someone from doing exactly what we just did, so that going forward, you are safer, your data is safer, your systems are safer. This right here is a model published by Lockheed Martin. This is called their cyber kill chain, and it describes 7 steps in the penetration testing process, starting out with gathering information about your target, then actually breaking into it, and then establishing persistence, and reporting out and exfiltrating data, things like that. Cool. Yeah. What is this? No, this is the Leon. Okay. Okay. Yeah. So we get to do a little bit of that right now. You're going to do a small scale penetration test in your Kali machines. Go ahead and open a terminal. I believe you can do that with either Control T or there should be a little black terminal icon in the top left corner. I see people reading the slides. Those are examples. Please feel free to look at them as examples, but we're only going to be using part of one of them for today. All right, let me know when everyone's got their terminals open. I'll give it a couple moments.
Yeah, so we're going to go ahead and demonstrate alongside you guys. Let me go ahead and...
All right, so everybody.
Well, just do that. Computer audio. Yeah, we'll just admit that. But
Testing. Hopefully, okay, that sounds much better. All right, apologies for the echoing stuff there, and thank you, Alex, for your assistance with that. But yes, everyone should see their Kali terminal.
It's I need to authentication is required.
when you embed the IP address in the port.
Not control.
Oh, okay. You can just type it in Kali, or the password. It's the same one. Yeah, the same other things.
Good, Logan? Cool. All right. So we're going to start by scanning our target, and the target that you have all been deployed should have been included in that email that you received. It should be an IP address starting with 192.168, and your attendee number is the 3rd octet. So don't copy what you see exactly that I'm going to type in, but I know Alex's is going to be Nmap service version. So I'm scanning for, kind of remember how I was talking about ports on specific, or communicating with specific ports, where the SV flag basically says that Nmap is going to scan for and try to detect the specific service version that is listening on the ports that it finds. So I know my target is 192.168.0.10. You all should have a unique but very similar IP target address. I'm going to press enter. And basically this step is I'm gathering information about my target. What is running on their machines? What can I exploit? Because if they don't have services, they cannot be exploited, right? That is the concept of attack surface. So here I see VSFTPD 2.3.4 running on port 21. And yeah, that is open. For the sake of time, I'm going to skip over kind of the research portion of it. Or you know what? Yeah, we'll go ahead and do that. Go ahead and open a Firefox browser. Oh, nice scroll. Oh, 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 goodness. Okay, I'll just search up here.
So a little bit of a tip for this workshop. When you connect to the machine through the RDP client, it is sending the video information out through the internet, and it can be really, the bandwidth can be really slow. And if you scale your window to fit the max resolution of your screen, and it's too slow for you, like it's chopping up when you do anything, you can reconnect to the RDP machine. You can reconnect to the Cal machine, and it should reset the resolution for you. So for this workshop, I'd say we'll say we're just going to keep it at the default resolution. So don't scale the window if you have clicked those buttons.
Thank you for that, Alex. Yeah, so in your Firefox window, we're going to do some additional research. So I've done all the research on the VSFTPD 2.3.4 for when I did this demonstration a little while ago. But for those who may not have heard of this service before, it is a very vulnerable service. But how would you know that if you just saw that? So we're going to do some research here. We're going to look into the National Institute of Standards and Technology, or NIST, and research their National Vulnerability Database, or NVD. I'm going to go ahead and hit enter there. I'm not a robot. Oh, great. One, two.
I also ran into this, and it was just repeatedly giving me the checks. I just went to DuckDuckGo.com and searched stuff there.
Oh, it was giving you a security check?
Yeah, I did the same thing too.
Yeah, it's because it recognizes that you're trying to connect through an AWS machine, and those are most commonly used for like a lot of automated tasks on the web. They probably think you're web scraping. So like,
What's the URL?
I just searched for NIST, or National Institute of Standards and Technology, NIST, National Vulnerability Database.
I mean, do you actually have to do this on the VM though?
Yeah, that's okay. Yeah, if this is going to continue, then we'll just skip this.
Yeah. So go ahead and look that up on your actual web browser, not on the client.
Yeah, we'll skip this. That's unfortunate. I didn't foresee that coming. But that is a source that the national government maintains of known vulnerabilities that contains information on this particular service and its vulnerability there. If we were able to look that up on the database, we would, I believe there is a sentence on there that says there is an exploit available on Metasploit, which is the next tool that we're going to use. So we're going to go ahead and search, or in your terminal, do sudo msf console . Going once, twice, 3 times, sold, enter. That's going to take a minute to boot up. And the Metasploit console, or the Metasploit framework, is a free and open source repository or giant database of exploit packages and tools, and like automated penetration testing tools that can be used to assist with your red teaming operations. All right. Cool. So everyone should have now a little MSF terminal down there. We're going to go ahead and query this giant repository of exploits for a very particular exploit that targets this vulnerability in the VSFTPD 2.3.4 service. So we're going to do a search. What type of thing that am I looking for? I'm looking for an exploit. And I've got a keyword here of VSFTPD. Let me enter that here. Search type colon exploit VSFTPD. Search type exploit VSFTPD. Okay, cool. And I hit enter. And lo and behold, I've got one exploit that conveniently is ranked excellent. So hopefully this works because that'd be quite embarrassing. But this is the VSFTPD smiley face backdoor vulnerability. It should give you complete access to a target that is vulnerable to this exploit. To use this, we're going to go ahead and enter use. Oh, wrong. Use. And I could type out the name, or if you are looking down there at the little instructions down there, you can see that you can enter kind of the index position of that list. So I'm going to enter use 0. And now I'm in that exploit. Use 0. Now, you're welcome to also follow along with this section, but it's not critical. It's not necessarily required. But I believe if I do show options, I can see the, I can see, running show options will show kind of like different required settings for a particular module to work. Down here, we can see our hosts and our port is required. Our port is 21. That was the port that our target had the vulnerable service running on. And our hosts or remote host is the IP address of the target. And you can see that it's blank. So we need to set that before we can run this exploit. And we do that by doing set our hosts and then your target's IP address. In my case, it is 192.168.0.10. But your third number should be changing depending on your attendee number. Set hosts 192.168.0.10.
Oh, you moved that cursor. Right. Oh.
I'll give it a couple moments more. When I hit enter, you should see a little rhost with an arrow indicating that your rhost setting has now been changed. Now for the fun part. And forgive me because this has been a little bit finicky in testing, but we're gonna cross our fingers and pray. The cool part, we get to do exploit. Enter. Haha, I'm in.
Oh, not yet. So, a second. So it goes through several processes to actually execute the vulnerability. But now we actually should be in.
Yep. So yeah, right here we can see that I've found a shell and opened a command shell session on the target machine, which means I am currently within the target. And I'll kind of show what that is in a little bit. I see a question on Zoom. Your target IP address should be, or it'll be the third number in the email that I sent you. It should be 192.168.a number. I can check for you if you can't find it, but that'll be in that email, the second IP address.
They're labeled, it's either labeled target VM or private. Okay, got it.
Target private IP address.
Okay, cool.
Everybody get to this point? Cool, cool. No, not working.
Did it say asking for a password? Oh, yeah, so. Search VS, we're gonna be searching for VSFT.
Ryan, have you logged on to the Kali machine already, or are you in the MSF console?
Oh,
Okay. In that case, what you could do is try restarting the command. So once you've selected the terminal, I'm going to hit Control C. Or actually, if it's still prompting you like with the MSF prompt, you can just type in exit. To take you out, and then you can run through you can do sudo MSF console again. Yeah, usually if it asks you for a password, it means the exploit failed, and you'll probably have to run it through again. Hopefully on the second try, it should give you that. An exploit should run through.
I don't think it requires help, but setting specifically in all caps, so I was just gonna, and then for email should have it. Everybody good?
Cool. All right. Now, you all get to use a little bit of the file system knowledge that Alex kind of imparted upon you. And there is a flag.txt file hidden somewhere on this system. You can use your cd commands, your ls commands, etc. To try and find that. I'll give you a hint. You should probably go 2 directories up from where you currently are within your system. I can kind of show that it's kind of a mess where you spawned in. Yeah. Oh. Or maybe that was in there. And then if I do an ls, there's a bunch of stuff in here. All of this was part of our efforts to make this system intentionally vulnerable. So you can kind of, I'm telling you right now, you can safely ignore it. And then did you cover PWD in your?
So let me go ahead and show you guys. I believe it wasn't on the slides, but for finding this flag in this machine, figuring out where you are exactly can be done by typing the command pwd. So then it shows us that we're onto the home directory in the Ubuntu directory or user. We're in the folder that says vs ftpd lab, and then we're in wherever that is. And what you guys are tasked with is trying to find a flag in one of these directories on the system. So if you have full terminal access to this machine, usually you wouldn't be able to connect to it through SSH, which is the proper protocol that you use to connect remotely. But you can go ahead. We'll give it 5 minutes for you guys to explore a bit in the machine. The flag should just be called flag.txt, I believe. If you guys need help with navigating in the terminal or commands, let us know. And also let us know if you found the flag. That's bad. Okay. I wanted to put like a YouTube link instead. Yeah, it's just that. Yeah, we didn't put it in. I'll take extra stuff.
I wish.
Yeah. You can't let it in.
You guys plug it? Yeah.
I'll say it.
Yeah, this is all kind of dependencies. I had to like manually install the
vulnerable to it.
Just leave it after.
All those dependencies. So you
I
can
mean,
look at and you just see.
It happens. But that was flag.
I'm stepping this.
Huh?
I'm stepping.
Right there.
Slash. Slash.
Can you find
Now,
out? Like,
your files is your missionaries. Just create your files down there. So you've got 2 folders in there. That's and the XMPP.
There,
So it's actually pretty fast. Yeah, just like.
Yeah,
This is right.
Or it's like a little bit like
so. Dots.
That's what Brit does.
It tells the file system of the terminal wherever I am currently located, like by point on the map, essentially. Dot it tells it where I am. Go back. So you can kind of imagine like a file system that's a higher tree. I think that kind of came up in that video. But when you tell it slash is go up the step, right? Whatever the like if you put a folder in a folder, going back to the folder. You guys are routine. Oh, so yeah, so that very cool thing that you made like.
So there is a file on the machine and one of the directories. So your task is to kind of navigate. That's the folder that we started once you connect your machine. Yeah, so we can go back to that folder if you go to CD.
Yeah,
sure. Something CD space tilde. So let me open a bunch of that. I think it was on the slides, but I forgot to mention it. If you guys are ever lost in the machine, typing in CD dash tilde will take you to the home folder of the current user that's logged in. In this case, it's root because we actually didn't mention that. So when you executed this vulnerability, you have complete root access to the machine. So don't delete any files just yet, but just know that that vulnerability allows you to get full root access for machines.
What is the planetary?
Yeah. Yeah, try going back to the home directory and then just looking for a folder there. CD space tilde. So tilde is that's yes, we go under there.
So if you're seeing a massive list of
So PWD stands for sorry. So PWD stands for print working directory. Usually, if you go to like a regular terminal, it would actually show you what current directory you're in. But with this, with the Amazon console, it doesn't want you to do exploits. But you can actually navigate to the slash home directory.
It's in one of these
forms.
But
I don't know, mine says like not connected now. And then what can I say?
You said you saw it?
You might have to.
Got him. I'm just kidding.
Control C.
How are you guys doing on Zoom?
So Control C stops the current task. It's a bit small. You can also this flag. So you actually increase the control space or that will increase the size of the terminal. You can go ahead and abort the session and then go through the same Amazon console steps that we do. Yeah, start the run. And find it.
I found it.
And flag.txt. Okay. So then, how would we be flag? I think it's 2 flags. Is there 2 flags?
Unless he modified the code without me.
No, I was just messing with you. Well, you're welcome to the machine now. So for reading files, you can also use, or for printing files, text files out to the console, it's cat. Yeah. And that'll print it out to the console. There are other couple ways to read text files and using a console, but we'll go over that
Okay, so does everybody here have a fun flag? In person and on Zoom.
You found it. You guys found it.
If not, we'll just go through the walkthrough real quick. Yes, it is flag.txt, but how do you read it is the question. Yeah, Nano is a way you can use to read text files. If you just type in nano flag.txt, it'll open up the editor for you, and then you'll be able to read that file from there.
You can also use cat.
Yeah, so you can also use cat. Cat as well. Cat prints the text from a text file out onto the console. Other ones, we'll get to that in a bit. Less is one of them.
These two folders I had to do something to make it. So you can go ahead and go to certain people. What was the first? Oh, yeah.
Or you paying for that. That's what we paying for that, actually. I'll make sure to send out a check. Okay. Did you go over the walkthrough real quick?
Yeah. I think most of you all should have it by now, but for those who maybe are still catching up, feel free to follow along. Yeah, I'm at root currently, so you're going to want to navigate to the root home Ubuntu directory first. In that directory, we're going to see there is a FAST folder and there is a VSFTPD 234 lab folder. We're going to go CD into the FAST folder, and then we're going to list out the contents of that folder there. And inside there is a cat flag .ext. Y'all just got rickrolled. I'm just kidding. All right. But yeah, so what this kind of simulates in these CTF or capture the flag style type of games in the cybersecurity industry is you would be given kind of a machine like this, and you would try to go find these flags. And this simulates you're an attacker or a pen tester, and you're able to find these sensitive data hidden throughout a system. In this case, this is not, I'm not trying to expose anybody's actually sensitive data, so you get a harmless little rickroll like that. But yeah. Cool. Then with that, I think we're good. Did we want to go back to the slideshow?
Yeah, let's
just go back to the slideshow. And then start back up on that. Stop share, please. So confused. This is embarrassing.
I think it probably crashed. Okay, that can happen. Yeah, imagine probably crashed.
Technical difficulties, as per usual. But yeah, hopefully that was kind of cool. You did your first reconnaissance of a vulnerable system, found a vulnerability, and then used a database of tools to exploit that vulnerability and found a small little tidbit of information on the exploited system. So that was cool. Um, is Zoom just not working?
It crashed, it froze it, and I had to end the process manually. So, please give us a second to reconnect back to the Zoom meeting. Let me go ahead and share on this side.
Okay, cool. Yeah, these were kind of just the slides explaining conceptually what you just did. But yeah, scan it, exploit it. Cool.
Okay. Get the green shield. Okay, cool. So with that being said, after Metasploit framework, we can move on to our next pen testing tool, which is aptly named John the Ripper. It is a popular password cracker program. And what it does is it uses a variety of methods to crack things like password hashes, which I can explain here. So how many of you in here know what a hash is or know? Okay, so essentially how passwords are stored in applications, they'll typically not store it under a file, in a text file, with just your password, right? They're going to ideally, if they know some security fundamentals, they would be using what's called a hash function to hash that password into a sort of unrecognizable array of numbers and characters. If you look at the diagram there, it kind of, well, it shows what the process is like. The keys section shows the input data that's going into the hash function. And it's using a variety of mathematical methods to convert each character into a fixed array size of bits. And so, for example, we'll take John Smith, run it through our hash function, and it'll give us the hash number of 02. If we do Lisa Smith, it'll give us a different, but also random but unique hash number of 01. Sam Dell will give us 04. But then we get to Sandra D, and for some reason we get the same hash value of 02 when we run the function. So one of the vulnerable flaws of password hashing or hashing in general is that all hash algorithms and functions don't have perfect one-to-one mapping. Some keys, when they go through a hash function, they will map to the same hash value. And John the Ripper also can exploit that as a way to crack or get the original plain text of a hash file or hash value. So we can go ahead and go over to our VM machine, and we'll do a demonstration of John the Ripper. Navigating onto your Kali machine here, we can go to, if you're still in MSF console, you can go ahead and just close it out. It should close out fine, and then when you reopen the console, it should be blank and it should take you to this prompt. So we are. So what we're first going to need to do is to create a actual password hash, and there are a couple of variety of ways to do that. One of the ways is using a program or a couple of commands. So go ahead in your consoles, go ahead and type in echo -n, and then quotation mark, open quotation mark, and you're going to enter in a password, not just any password though. We're going to be entering in a very simple, very generic, maybe even one word password. You can use like any word in the English dictionary. You could say apple or banana. You probably add a number to it. Don't make it too complicated. Just do a word, maybe a number. And so for this example, I'll just type in, I don't know if Caleb is in the dictionary.
It's spelled with a K. I don't.
Yeah, it might not be. Okay, fair. Okay, let's just do.
The most secure password ever. Admin.
Got you. I will use admin as the password. So then, before we type that in, or actually, let's type that in and then let's hit enter. So I can explain to you guys what echo does. Echo basically just prints a text that you wrote down to the console. The -n flag there just specifies no trailing white space. You don't have to worry about that. But let's go ahead and re-enter that command back in the prompt. You can easily do that if you press up or down on the arrow keys. It'll take you back to the past commands that you've used in your history. So we can go back to the echo command, and then we can take a look at. I'll just go ahead and copy and paste this here, and I'll explain it to you guys. But we're going to type in that, and then this character, which is the pipe symbol. What the pipe operator does is essentially pass on the output of one command into another command. I'll go ahead and I'll type the full command in the Zoom chat for those who would like to do so, but go ahead and type in just this full command, and I guess while you're typing it in, awk is another program that is basically a helpful utility to format different files and things from the console. In this case, we're not going to be covering it just for the scope of the workshop, but we'll go ahead and type in just that. This operator right here allows whatever it is in the console to actually output and write to a physical file, a digital file on the file system. So once we've put in that command, we're going to go ahead and hit enter. Nothing is going to print out. But if we go to ls and then we cat our simple underscore hash file, we can see that we've got a random assortment of bits and numbers. And if you compare to somebody who has put in a different password for this command, it's going to be resulting in an entirely different array of random bits and bytes. And the hash algorithm that we're using converts the text to, I believe it's 32 characters. Correct me if I'm wrong. But each hash function specifies not only the hash size, but also some other different mathematical algorithms it uses to hash the text. So once we've got that hash file or hash text, what we're going to go ahead and do is we're going to select it, and we're going to hit. Actually, no. We can go ahead and enter or start using John the Ripper. So John the Ripper on Kali is a command line utility. it is simply just named John as the command. We can put that in, and then we just type in the file name of the file with the hash that we want to crack. And then if we just hit enter, it's going to throw a bunch of stuff. What it's doing right now is it's doing what's known as a dictionary attack or a dictionary lookup attack. How John the Ripper in this instance is going to work. Oh, whoops, sorry. Forgot. I've got one more option. So if you guys ran that command, go ahead and press Control and C, and that should stop it for you. I forgot to specify the format or the hash algorithm. So that's the full command that you should be entering in. So if we hit enter, bam, we reversed the hash from, we got the plain text file from the hash, which is something that if you were to do by hand, even if you knew the hashing algorithm, would take a very, very long time. But in this case with John the Ripper, with this dictionary attack, it uses a file called a word list or a dictionary, which has a list of pre-calculated hashes. So in this case, it was able to crack the hash for admin pretty quick because in its word list or in its dictionary, there was already a pre-calculated hash for admin. So all it did was just look up the hash number, and then it shows up right next to the admin plain text. Let me know if that didn't work for you guys, because then that's probably a matter of the password that you entered in. It was probably too complex for this regular attack. Yeah, did you have a problem with the?
I didn't have a problem, but so we use the ND5 sum awk to.
Oh yeah, I can.
And then we use it again for John to break it, or crack it.
Yeah, so this is the initial command that you're going to be entering in, just to create the file, a file with the hash of your password in it. And
So if like we like join into a system and it's already hashed, you don't need to like do that.
yeah, that's just to create a hash. When you're doing pen testing and you're not cracking to an actual system that you're not allowed to, enter, a lot of the passwords will be stored in some text file somewhere in the server that'll have these hashes. It'll probably also be encrypted with another layer, but it'll probably be stored as a hash text. Then you'll be using John the Ripper to either take that huge file with hashes or maybe just a single hash. We can actually, so John the Ripper is, many of these commands have different options to customize the usage of the tool. What we did here was do the general usage, which is just John, and then specify a file name. We can also just do, if you have like a single hash that you want to crack, that one, we can just, I believe, this is where man comes in handy. Manual. Oh, right. I think if you just put in the hash number, it should be fine. So let's try that. Okay. In this instance, no, you will have to put the hash in a file or a text file for John to crack it. So that was using John's just regular John the Ripper's dictionary. There are many other, so of the John. Okay. Yeah, I can run it one more time. Oh, so what? Another functionality of John. In this case, it's a kind of a nuisance. Once you've already cracked a plain text file and you go back and you cat it'll store it in its internal like cracked passwords database. So I think if we go ahead and Um, we would have to reset John the Ripper, the database for John the Ripper. And that is by okay. Well, where John the Ripper stores its list of cracked passwords is in the home directory under .john and then john.pot. So like if we cat john.pot, it shows us that the hash file or the corresponding hash text corresponds to admin. So if we remove that file and then run through it again, it'll recrack it. But just a real shorthand, you can just remove that file and then recrack it by typing in rm tilde /john/john.pot. And that's going to remove the remembered lists of cracked passwords. And then we can just run John again on simple.hash. And it'll crack again. So let's go over using a different word list for John the Ripper because there are. Question?
For some reason my no password hash is loaded.
Did you output the hash to a file?
Yeah, that's right.
No, it's a little weird.
Put it, and you do press control and then your plus gun, it'll increase the size of the terminal. So easier to see. Control and then or touch it. Control shift and there we go. Okay. And then go ahead and run that command. Yep, and then you go do the John command. Yep. This the hash, not the fix. And then you can go ahead and run the item command again. And then okay. In that instance, I think your John Ripper might have not been configured properly. You're ready for the first time. We can try, you'll be able to go through this next example though. So let me show you another way of how John Ripper works. So we can use a downloaded word list from the internet, but in this instance, it's already on Kali Linux. So if you go ahead and type in gunzip space /etc or sorry /usr share wordless. Probably. Word lists. Oops. Okay, sorry. Let's go ahead and try to find this word list real quick.
Also new because we're like down to our last 30 minutes. So we'll just skip this particular one.
Okay. We might have to skip this example. Do you have the word list on your machine? Okay, interesting. Okay, so yeah, with I guess with our configuration of Kali, you didn't install the word list instance or word list file. So we'll just have to move on with our next example. But just know that for password cracking, if the regular tag doesn't work with John, you might have to find a different word list, and then you can specify that with John dash they just word list equals. It's a flag. It'll be a flag that you'll have to create. But anyway, moving on to our next tool. Sure. We're going to be going over a little bit about network security. So network security is a specific subtopic of information security, where it's more about the live analysis of network traffic within a network. So if you are either on a blue teaming role, like for example, like a SOC analyst, you would be using a wide variety of network tools to monitor, detect, and to monitor network traffic, detect any suspicious activity on the network, as well as mitigate it through a variety of tools. But the tool that we're going to be covering for this workshop is a very simple tool called Wireshark. And what Wireshark does is it can capture live packet traffic as well as analyze it. So let's go ahead and go through that example here. Okay, so we can go ahead and close out this browser. And Wireshark is a tool that has a GUI interface as well as a command line interface, but for simplicity of this workshop, we're just going to be using the GUI. We're going to be using the GUI. So if you press on the Kali Linux logo and then just type in Wireshark, it'll open up it'll show this prompt here. This is essentially the sudo authorization, because you will need sudo level privileges to access some features of Wireshark. And then the password there is just Kali 2025 0919. So that should open up a nifty little window. I know it's a bit hard to see with the Kali 2025 0919. And then, so we get this nifty little GUI here. It's a bit hard to see because a lot of it is cut off. But for the most part, we're just going to be looking at this kind of area section of the UI. You're going to see a cool little shark fin icon here. And what that does is it's going to start capturing live packets that are traveling through your network interface, which essentially is what dictates, network interface is what dictates or what directs the traffic that comes in and out of your machine. So we can go ahead and press that little shark fin icon there. And so there's going to be like a bunch of packets. So we can go ahead and stop that. I did not expect to actually shoot that many packets out. But yeah, so that is the kind of packet capturing process. As we've discussed a little bit earlier in the workshop, live data that's being transmitted between devices and computers inside a network are organized in what's called packets on the transport layer. And packets contain a number of useful information. They have the destination IP address, aka where the packet is going to, as the source, which is where the packet is coming from. It shows the timestamp of when the packet was traveling through the interface, as well as what protocols it was traveling with, its length, a little bit of its info. I wish I could zoom out a bit more here. If we just look, so the bottom half of the GUI actually shows a little bit more information about the packet data. So if we select a packet here, it can show you just the frame number, some data about the information about the protocols, as well as the actual data that was sent in the packet. So this format here is called hexadecimal. It is 2 characters. A lot of this information. Yeah, so if you keep on scrolling to the right of this panel, here are the actual like unencoded or de-encoded characters from the hexadecimal code. So that's a bit of a deep dive later into networking. It's a pretty huge and complex concept, but if you learn networking and know sort of how packets move and travel and how to secure systems and monitor packets, then it is a great sort of subcategory to explore on your own. So that was a little bit about Wireshark. One thing I was going to cover is the opening of Wireshark capture files or .pcap files. Let me go ahead and go back to the presentation here. I don't actually have the image, but PCAP files are basically live capture data from Wireshark, and then you can save that output to a file which lists all the data that was captured from that packet capture. Okay, so on to our next tool, which is cryptography. Here to present that, we'll be switching over to Caleb so I can get some water.
And I think yours crashed again.
I haven't turned it.
Oh, don't.
Hit. Crashed again. Though.
It's unfortunate. Okay. Okay, yeah, for sure. So cryptography, very similar to the idea of hashing. You're using mathematics to scramble up any data that you don't want anybody who's not authorized to see it, to read it, even if they do get their hands on it. And that's very critical to protecting data at rest, in transit, and in use, which is kind of 3 common times that you'll hear repeated throughout the industry. We can use a couple of tools, including crackstation.net, to read, to break through kind of these hashing and cryptographic functions. So yeah, I'm trying to keep it quick, but feel free to, in your Kali machines, open up a Firefox window and search for crackstation.net. And then in a, so I should probably,
This is fine.
well, we've got a file on your Kali system pre-installed, and it's called super secret message.txt. It'll be in your fast folder. You can go ahead and open that up. You'll see a bunch of hashes that Alex was talking about before, and we can paste those in. I'm probably about to get a bunch of rather annoyed looks in the room because I'm so creative.
Yeah, so we're gonna go ahead and crack just the first line of the super secret message.txt file. And
was gonna ask you to do the capture.
Oh, you're all getting the capture? Yeah.
No worries. We can just look on the.
Why? It's timing as well.
Oh.
I might ask you to go something.
Mistake character.
You good?
Yeah, I would do it on the VM, but like it's just way too slow.
Yeah.
So, should we just
I went through the capture just like on the board of
oh for the actual website? Okay. Yeah, we'll skip through it. Probably just yeah.
For sure.
Okay, well, if you have hashes, you can plug them in there. It's got a lot of pre-computed hashes that it can kind of reference, kind of like what Alex was saying previously. We pre-computed the value of admin, for example, and we know the hash value, and it just references that. Very similar thing here, cyberchef.io. Feel free to Google that on your own time because I don't want to keep you guys past 7 if we don't have to. And it allows you to create a bunch of different combinations of cryptographic and hashing functions, and it can analyze based off of the output of a hash function what function it thinks it was used.
We could go through that a little bit.
Oh yeah, I can.
So this is what you guys can do on outside of the virtual machine. You can go to cyberchef.io. It'll take you to a cooler website, and it is a sort of like a cryptography multi-tool where it'll give you a million different encryption, decryption, and hashing algorithms. We can just go do, for example, we already did hashing though, so that's not fun. Let's go do Caesar cipher, the classic encryption scheme. No, not Caesar like Caesar Chavez, but Caesar, as in the Roman Caesar.
I cannot spell.
C-A. Oh, so, yeah. E-S-A-R. I think it should be on there. Oh, it's called ROT. Okay, so it's actually called ROT 13, which means that it's just the number of characters that the encryption will go through. And in the input field, you can type in whatever plain text messages you want. So, for example, type in something. Okay.
Yeah, to demo what that means, first off, if I do ABC, you can see that each letter gets moved 1 over. So that's very simple math there. So A becomes B, B becomes C,
Yeah.
etc.
Yeah, each character gets shifted 1 amount to the number that we specified. But if we specify it to the amount of 13, each character will be shifted 13 places up the alphabet.
Is it Labubu or Labu?
LA. But yeah, so that is CyberChef. There are a couple of other functions on there besides encryption that are maybe useful for things like forensics. So yeah, we can move on from the. You'll also be able to upload things like files to CyberChef. There are so many tools on there. I encourage you guys after this workshop to just kind of explore the amount of functions that are on CyberChef. Cool.
Okay. Yeah. Speaking of forensics.
Yeah. Speaking of forensics, forensics is a really cool field of cybersecurity that deals with the collection, analysis, and presentation of digital evidence. It really is about just becoming a detective and reconstructing a timeline of events on, for example, a device or a computer that has been attacked, breached, or had a malware infection. There are usually like breadcrumbs that you can find on that machine to reconstruct a timeline of events. That essentially is what digital forensics is all about. We can go over. There are a lot of forensics tools out there. One of them being a sort of not really forensics tool, but it is a database viewer. And what a database viewer does is opens up a .db file. And the reason why this is so important is because for a lot of server applications and things that deal with user-facing applications, a lot of user and client data is going to be stored in what's called a database file that's in a database server. And you can see just the variety of database servers out there. But they should all be using storing their data in a .db file. And so a .db file can contain just regular plain text, things like images, and it is also one of the most common attack targets for attackers because it contains a lot of potentially profitable information like email addresses, first name, last names, actual addresses, things of the sort. We can go over the database viewer real quick. So let's go ahead and go back to our virtual machine. Okay, so now we're back on Kali. We can re-log in if it logged you out with just the password again. And so there is a neat little application installed on Kali called SQ, or I don't know, did not install here either. That's not good. That should be under the forensics category, I believe. Okay. Yeah, it didn't seem like installed on deployment. But yeah, there are actually a variety of database viewers out there, not just the one you can find on Kali Linux. There are database viewers online as well. But we're going to walk through this database file under the fast folder called northwind.db. And as you can see by the size of the database file, you can tell that there's just a lot of information stored in this database file. If you'd like to, you can go on to Firefox and then browse it there. You can also download it online. It's available as a GitHub file. We can send it out if you guys would like to learn more about forensics. That being said, let's go over back to the slides here. And we can just talk about some other topics that may be of interest. These are we can talk about some other topics that have tools already pre-installed in Kali Linux, or in most Kali Linux instances, not this one. We can go over, or using a tool called SQLmat. You can do things such as SQL injection, I believe S scripting, which stands for cross-site scripting. Burp Suite also is a just overall web security platform that can analyze TCP data, HTTP requests, and all that cool fun stuff. There are also a lot of tools for OSINT. Google is a tool. I mean, it should be obvious, right? It's a search engine. But you can find a surprising amount of information on potential targets, I would say. So OSINT is mostly used for things like law enforcement investigation. But if you participate in MCL, OSINT is a really fun category that you can play with. And you'll be using things like Google and tools found on the OSINT framework to investigate and browse the web to find information about a person or a company that's targeted. We can also cover a bit about reverse engineering. This is popular for reversing malware. So there are tools like Ghidra and Radar2, which can dump the code of a malware artifact or file or executable, and we'll give you the basic machine code, and it'll translate it to a high-level code, such as if a piece of malware was written in a language like Java or Python, and it was compiled to raw code that you wouldn't be able to read just through like a text editor. Ghidra Runner 2 will reverse that process and make it easier for you to understand and basically reverse engineer a malware, its inner workings. Next slide. So that will be the end of our tool coverage, but there is like so much more you can do with Kali Linux. A regular installation of Kali Linux. So if you are able to spin up a virtual machine and then just install Kali Linux on your own, there are, I'd say, just a multitude of different tools out there. A multitude of different tools, and with each of their own categories that we didn't get to cover in today's workshop. And to that end, I'd say for learning a lot of different cybersecurity concepts and just kind of expanding on your knowledge set, we say the fastest way to grow and to learn is to find your niche, whether it be forensics, pen testing, reverse engineering. Find your niche and then start to learn a lot about the tools used in that field. So if you want to go into pen testing, start learning more about SQL map and cross-site, learn more about John the Ripper. SQL map will be more for like web security, but you can also do pen testing with web security. So build that toolkit and always stay hungry for knowledge. A lot of the tools in Kali Linux are well documented, so you can easily find resources available for each tool online. They're actually maybe they're probably under the official Kali Linux website. If not, each tool is free and open source. There will be a GitHub repository where you can actually look at the code. Maybe there'll be some more documentation available for usage of that tool. And there is a great quote that I want to shamefully requote from Hank Green. He made a video called "Don't Follow Your Dreams, Follow Your Tools." And what that means essentially is wherever you want to be in your cybersecurity career, don't think about trying to go for example, a CISO. Maybe you don't want to go that high. Maybe you want to aim for like a regular security analyst. Don't try to think about becoming a security analyst. Think about, okay, what tools does a security analyst use in their daily work? What kind of methodologies do they use for their work? What kind of skills and tools do they use to become a security analyst? And by kind of putting yourself in however extended you are into that role, even if it's just like dipping your toes in just a little bit into what a security analyst would be, not necessarily putting yourself in charge of like a whole organization, you can really learn fast don't take a shot. You can learn very quickly on learning how to just to become your dream role. And yeah, with that being said, that concludes our workshop. Our next meeting next Tuesday will be with Max Sipiel. He is with Sumo Logic and he manages I believe the SIEM. So real quick, SIEM is the acronym for a security
Information event management system. It is essential for a lot of cybersecurity analysts, security analysts for big companies. They'll use a tool such as that to analyze. It essentially is a big catch-all monitoring tool for networks. And yeah. So basically, if you remember from when Alex started packet capturing and like ran Wireshark for half a second and his screen got like blown up with logs, that's what organizations deal with on a day-to-day basis. And a SIEM or SIEM, Security Information Event Management System, helps organizations quickly aggregate and parse through and analyze all that data to be effective in their response times. Yeah, so if you're interested in learning about that, we'd love to have you. That'll be next Tuesday, 12 to 1 at U Hour. Yeah, anything else? If not,
no, I think that's end of the workshop, everybody.
All
Thanks
right.
all for coming.
Yeah. Thank you all for coming online. Thank you all for coming in person. For those in person, we're going to Denny's after. We'd love to network dinner with you guys. So we can carpool, meet us there or whatever. Yeah.
If not, if you got a long drive, definitely appreciate you staying till the end.
Are you supposed to use slides?
Yeah, we'll be watching the slides
Yeah.
afterwards.
Great. Alrighty.
Were there any last minute questions on Zoom before we end the meeting?
We're going.
Really close up. Microphone. Okay.
Right.
Not, thank you guys coming virtually. We hope to see you guys in tomorrow's next week's Tuesday meeting. Thank you guys so much.